A little while back, we talked all about how AI stores information on the outside, in regular old databases. But what about what's going on inside its head? Today, we're diving deep into the machine to really understand AI's synthetic intuition.
And see, here's the really mind-bending part. Modern AI has this built-in way of remembering, this kind of internal gut feeling. It's a way of knowing things that doesn't involve looking up a single thing in a database.
That is the big question, isn't it? So, how does it all work? We're going to pull back the curtain and take a look at the surprisingly complex, almost biological way these models hold on to information. To really get this, you have to completely forget about neat tables and columns. We need to start thinking about a living, breathing, internal world that's constantly learning and changing. Think about it. When you feed a large language model trillions of words, you're not just dumping text onto a hard drive. No, you are carefully, meticulously sculpting this incredibly complex landscape of connections and patterns. It's way less like a library and honestly a lot more like a brain. Okay, so let's get into the foundation of this internal memory. We're going to start with the model's long-term storage, which you can kind of think of as its waitscape. Right, so weights. They are the absolute bedrock of a neural network. Imagine billions of tiny little digital knobs, and every single one gets tuned just right during training. Now, they don't store raw facts like the capital of France is Paris. Instead, they encode the relationship between France and Paris as a kind of mathematical probability. And this sponge metaphor really makes it click. A sponge doesn't hold on to individual water droplets, right? It absorbs the overall shape and volume of the water. Well, it's the same idea here. The model's weights don't memorize sentences, they absorb the deep underlying structure of language and knowledge itself. All right, so that's the deep long-term storage. Let's move up a layer to the model's active conscious mind. This is its working memory, what's happening right now. So if weights are the model's huge subconscious library of everything it knows, attention is its conscious focus. It's this brilliant little mechanism that lets the model look at a whole conversation you're having and decide, okay, which words are the most important for figuring out the very next word I should say? But, and this is a huge but, this focus has a serious limit. The best way to think about it is like carrying groceries. You can only hold so many bags at once, right? The model's attention, what we call its context window, is exactly like that. It can only hold so much information. Once it's full, something old has to get dropped to make room for something new. So we've got long-term memory in the weights, and we've got short-term memory with attention. But how does the model keep all this organized? How does it know that king is related to queen, but not to, say, chainsaw? The answer is embeddings. Every single concept gets translated into a set of numbers, a coordinate, basically. It's called a vector, and this places it on a gigantic, multi-dimensional map of meaning. It's not a map you can see, but a mathematical one that's built right into the model. The easiest way to picture this is like a huge city map. There's a royalty neighborhood, and that's where you find the addresses for king, queen, and prince. Then there's the fruit neighborhood with apple, banana, orange. The model basically navigates this city to figure out how ideas are related and what to say next. Now, what's so fascinating is that this really elegant, intuitive system, well, it has some very specific, almost ghost-like flaws. And understanding these flaws is absolutely key to understanding AI today. You ever been talking to a chatbot and it completely forgets something you told it like 10 minutes ago? Well, this is why. Your conversation only exists in that temporary attention window. Remember the grocery bags? As you keep talking, the oldest parts of the conversation just get pushed out to make room. The model literally forgets how the discussion started. This also explains hallucinations. See, when a model doesn't know a fact, it doesn't just say, I don't know. It looks at its internal map and finds the most probable path, the closest neighborhood to what you're asking about. It's not lying to you, it's making an educated guess based on the geometry of its own knowledge. It is a pattern-matching machine, not a fact-checking one. So here's the crucial takeaway. To fix these flaws, you can't just build a bigger internal brain. You have to connect it to an external one. And this architecture is what's defining the entire next wave of AI. And here it is, the hybrid brain. You've got the LLM core, that's our thinker, the part with all the intuition. Then you have external databases, the fact checker, providing cold, hard, verifiable truth. And the magic connecting them is a system called RAG, or Retrieval Augmented Generation. It's the essential bridge that lets the thinker check its facts before it opens its mouth. And this, really, is what the future is all about. It's not a choice anymore between a model that feels right and a database that is right. The whole goal is to build a system that can do both at the same time.
And that's really the final thought here. That internal memory, the weights, the attention, that's what gives AI its incredible creative intuition. But the external memory, the databases, that's what gives it a grounding in truth. The most powerful AI systems in the very near future will be the ones that have absolutely mastered the art of blending both.